lecture series video of electric circuit analysis. Today's case study is about a problem. I will explain you, it will give me the answers, right? So keeping an circuit, ideal circuit, where current across the source is equal, where the voltage source is interchanged with any other places. So this statement is reliability theorem. Reciprocity. So anybody can explain the concept of the reciprocity theorem?
The reciprocity theorem applies to linear circuits, Ohm's law varied, bilateral components like resistors, inductor and capacitors, single source networks. It does not apply to nonlinear elements such as diodes and transistors, unilateral devices and circuits with multiple independent sources. This theorem is widely used in simplifying circuit analysis and validating network behavior.
So it is mainly used in bilateral or linear circuits, whereas the source is transferred to another branches, it will give the same current value. So as we have discussed about linear and bilateral system, so somebody explain to me about the case study scenario.
I will explain the case study scenario. It's concerning communication system, especially in a two-way radio communication setup. Station A transmits a signal to station B. Station B receives the signal through the network of transmission lines and antennas. Now, engineers want to verify if the same signal strength can be observed if the role are reversed. For example, station B transmits, but station A receives.
Okay. So in this particular scenario, what means by station 1 and station 2? She explained this. Anybody know about that? So it is the source where it transfer to the another sources. That is meant as station 1 and station 2. So here we are defining that as a station, etc. So next.
Next, we talk about transmission. During testing, engineers observe signal inconsistencies when switching transmission directions. The questions usually arise are: is the network behaving symmetrically? Are those losses affecting the signal strength? Can reciprocity theorem be applied to the validity system?
So network theorem is main application of this reciprocity theorem. So why? Because we are converting the networks from one source to another sources. So we are completely dealing with the network systems. So next.
Next, application of reciprocity theorem. They start with the position of the transmitter and receiver and measure the response. Observation: if the network is ideal, both currents should be equal. Any deviation indicates losses or non-linear elements in the system.
So I'm brainstorming question is that any circuit it is possible to be an ideal circuit in a practical scenario? No. So in theoretically we are achieving the ideal resources, but in practically we never get the ideal output which we expected. So is that ideal sources may have some losses, have some fluctuations, have some difference, so have some heat losses, anything. Okay, so no circuit is ideal when it comes to a practical experimental one. So next.
Next, analysis and solution. After testing, engineer identified presence of non-linear amplifier components. Signal attenuation due to impedance mismatch. Solution implemented: replace non-linear components with linear equivalents. Where possible, match the impedance across transition lines. Reduce noise and interference. The result: system behavior became nearly reciprocal. Signal strength improved in both directions.
So if you are transferring from one network to another network, we have to transfer the equal output which we are getting the first network, right? So if you are transmitting the sources to another network but getting a lesser output is not an achievable thing and not an advisable theorem to be followed. So if you are transferring the sources to another network, we have to obtain the same result which we have obtained from the first sources. So next.
Learning outcome. From this study, we learned reciprocity theorem helps validate networks symmetry. It is also useful in communication and signal transmission system. Identify issues like impedance mismatch and non-linearity. It simplifies testing by reducing the repeated measurements.
once we get the same level of values. So that is known as iteration. So by this iteration method, we can get the proper output from which we have applied as an input. So next. So all those things collectively known as the reciprocity theorem. So now we are in the part of conclusion. So anybody of you interested to conclude this reciprocity theorem?
Yes. The reciprocity theorem is a powerful analytical tool that ensures reliability and efficiency in electrical networks. Its application in communication systems proves how theoretical concepts directly impact real-world engineering solutions.
Okay. So if you are following on any one of the theorem, it will be highly reliable and efficiency method only. So if you are not achieving these factors like efficiency or reliability or stable conductivity, etc. So we are not following that method efficiently. So if you are following any of these methods, so we have to concentrate on the